Hello, so great to be with you. In today's episode of New Paradigm AI Research Summaries, we explore the thought-provoking subject of competitive programming with large reasoning models, a study brought to us by researchers from OpenAI, DeepSeek R1, and Kimi K1.5. Now you might be wondering, what exactly is competitive programming? Simply put, it's a mental sport where participants tackle complex, algorithmic problems within a limited time frame using programming languages like C++ or Python to write efficient code. Think of it as a coding marathon that tests one's problem-solving skills, logical reasoning, and knowledge of computer algorithms. In this fascinating research, the authors investigate how reinforcement learning, a type of machine learning where models learn by receiving rewards for desired actions, can dramatically enhance the performance of large language models on complex coding and reasoning tasks. Specifically, they compare general-purpose reasoning models, namely OpenAI's O1 and an early version of O3, with a domain-specific system called O1 IOI, which was specially engineered for the 2024 International Olympiad in Informatics, or IOI for short. The IOI is one of the most prestigious programming competitions for high school students worldwide, requiring participants to solve challenging algorithmic problems under strict time constraints. Achieving a high score in this competition is no small feat. It demands exceptional coding prowess and analytical thinking. The O1 IOI model utilized handcrafted inference strategies. In other words, human experts designed specific methods for generating and selecting the best code solutions during the competition. When they put O1 IOI to the test at the IOI 2024, it placed in the 49th percentile under standard competition conditions. However, when the researchers relaxed certain constraints, allowing more solution submissions, the model's performance soared to a gold medal level. But here's where it gets really intriguing. The general-purpose model O3, without any hand-engineered strategies, also achieved a gold medal at the IOI. This suggests that scaling up reinforcement learning enables models to develop sophisticated reasoning abilities on their own, reducing the need for human-crafted techniques. Let's delve deeper into how these models work. The O1 model is trained using a technique called chain-of-thought reasoning. This approach allows the model to generate step-by-step solutions, much like how a person might work through a complex problem by jotting down their thought process. It's as if the model is thinking aloud, which enhances its ability to solve intricate tasks. The O1 IOI model built upon this by fine-tuning O1 specifically for competitive programming. It incorporated specialized strategies during the testing phase, such as generating thousands of potential solutions, clustering them based on their results on test cases, and carefully selecting the most promising ones to submit. On the other hand, the O3 model represents an evolution in approach. Instead of relying on domain-specific, human-engineered strategies, O3 was trained with significantly more reinforcement learning compute. That is, it underwent more extensive training where it learned from trial and error. Remarkably, O3 was able to develop its own advanced reasoning strategies during training. When evaluated on CodeForces, a popular platform for competitive programming, the models showed impressive results. The O1 model achieved a rating of 1,673, placing it in the 89th percentile among human competitors. The O1 IOI model improved upon this with a rating of 2,214, landing in the 98th percentile. However, the O3 model outshined them all, achieving a rating of 2,724, which is in the 99.8th percentile, on par with elite human programmers. In the IOI 2024 evaluations, the O1 IOI model scored 213 points under standard submission limits, placing it in the 49th percentile. With relaxed constraints, it scored 362.14 points, surpassing the gold medal threshold. Meanwhile, the O3 model scored approximately 395.64 points within the standard submission limits, also exceeding the gold medal criteria without the need for any handcrafted inference strategies. These findings highlight a significant trend. While domain-specific strategies can enhance performance, scaling up reinforcement learning allows models to independently develop sophisticated reasoning abilities that generalize across tasks. This shift reduces the reliance on human intervention and suggests a robust path forward for AI development in reasoning domains. Researchers didn't stop at competitive programming. They also evaluated these models on real-world software engineering tasks using datasets like HackerRank Astra and SWE-bench verified. These datasets consist of practical coding challenges that require not just algorithmic skills, but also the ability to work on complex multi-file projects, much like real software development scenarios. On the HackerRank Astra dataset, the O3 model demonstrated significant improvements over previous models, handling intricate tasks involving frameworks like React.js and Django. Similarly, on the SWE-bench verified dataset, which focuses on real-world software issues with more reliable evaluations, O3 showed impressive gains. These results suggest that enhanced reasoning abilities in large language models extend beyond theoretical problems into practical, industry-relevant coding tasks. In conclusion, this research underscores the profound impact of reinforcement learning and chain-of-thought reasoning on the capabilities of large language models. By increasing both training and test-time compute, these models can achieve performance levels comparable to top human programmers, all without relying on handcrafted strategies. This progress opens exciting possibilities for applying AI in fields that require complex reasoning and problem-solving skills, such as science, engineering, and beyond. Thank you for joining me today as we explored the advancements in competitive programming with large reasoning models. Until next time, keep pondering the limitless potential at the intersection of artificial intelligence and human ingenuity.